Okay, so chapter 6 is techniques of micromotion study, and we're going to get into operation analysis. So there are 6 techniques in micromotion, and they are operation analysis, operator machine, then we have multi-machine, gang chart, left hand and right hand chart, and SIMO. Some people call it SIMO, it's the same thing, chart. Like I said before, motion study is all about charts. So out of 6, we're going to study the first 2 in details. So the very first one is operation analysis chart. So we use this for single activity, and that activity is broken up into elements which are then timed in decimal minute units. So here, this example table comes from one swing set. So what they're doing is they're packing a swing set, and you have 2 legs and 1 bar and 2 seats in that package. Okay, so the pack out operator is packing these parts into a carton. So that's your operation. So we can see right here the time is recorded in the decimal minute units. Okay, so that's 0.150 minute, and that's 0.065, and this one is 0.125 minute. So the operation analysis chart looked like this. So you have that scale is nothing but time in minutes. Okay, and we put the activity, these are the activity elements, and here is the line, and that is completely totally in line with your graduation in this time scale. So if you see this 0.150, and that's 0.05, that's 0.1, and this is 0.150. So that's how you are drawing in your chart. Okay, so here your operation is single pack out operation, and we'll put in the activity right there, so you can see it's bigger for that part. So 0.150 minute, your time is in minute, and you can also clearly see this time amount right here. Second element, third, and then the fourth is your idle time. Okay, it takes about 0.06 minute. And here you're gonna cross right there because the chart is operation. So we have other chart, operator machine, left hand, right hand, we have gang, and we have multi-machine. So here you're gonna cross off right there for operation. Description of your operation, we're gonna put right in there. Here is your name, who is recording this chart, your operation number, and then your part number, your date, and then your time. So when you look at it here, you're going to see 0.400 minutes per set. Okay, and that is your time, and minutes per unit that you're packing a single package with that rate. So now we're going to go to the bottom part. So when you look at this area, you're going to see this. So here is your hours per unit. So right now we're getting 0.00733, okay, hours per minute. So we translate that from the minute per unit into hours per unit. So that's your previous lecture in the other chapter 4. Okay, go back to that. Dollars per hour is right here, and then you're going to calculate dollars per unit. Pretty easy. All you have to do is just multiply this and that. Okay, and you will get 0.0733. only one decimal down because you're multiplying with 10. So that's your dollar that you spend for each unit, okay, labor cost. And here, when you look at it on this side, you're going to see the total normal time, and that's in minutes per unit. So every unit, we're going 0.400 minutes to finish that operation. And this is your percent allowance is a break. We call it a break. So that operator is taking 0.040 for break, okay? So the standard time, you add this, and you will get 0.440 minutes. And that the operator is spending to pack out one set, okay? Hours per unit, which is the same as that. Pieces per hour is you're going to divide 1 divided by 0.00733, and you're going to get how many pieces or units that this operator has made in an hour, okay? So here pieces per hour equal to 1 divided by 0.00733. That's because 1 unit is going to cost the operator 0.00733. So that's 1 unit divided by 0.00733 is going to give you 136 units per hour this operator is packing. So operation analysis chart you definitely need to know. And go back to your handout, and there's a detailed step-by-step. All you have to know is what that chart is, how to fill it, and how to calculate it. The math is super easy. It's only division and multiplication. And this is your operator and machine chart, okay? And here, the only difference is the operator machine chart is just a little bit more complicated because we have two activities. One is your operator, and the other one is your machine, showing their interrelationship. And we call that multi-activity chart, okay, because you have two activity, one for the operator and the other one is for your machine, and the rest of them are about the same, okay? So operator machine chart, we always have two charts. The very first one is your present method, and the second one is a proposed method. So we're going to take a look at your present method. So here, like I said, activity 1 is for your operator, activity 2 is your machine. So the first element, operator is loading, machine is idle. Second element, operator is idle, your machine is working. And third element, your operators is unloading and checking, your machine is idle. Okay, that's how we break down the operation into work elements. So both activity took 1 minute, okay? 55 pieces at 0.01833 hours per unit is done per hour. So let's take a look at the first part here. So here we're checking operator and machine because that chart is look like this, and we cross right here. The same thing, operation number, part number, date, time, and this is you, that is industrial engineer. So your title is going to be that. Even though we're industrial technology or industrial engineering technology, in the facility we go by the title of engineer or analyst, okay? And that's just a normal thing. So i.e. you're gonna write down your name, whoever take this data. And then here is your operation description, okay? So we go to the bottom of the chart and about the same thing here. So when you look at it, we're spending 1 minute per unit, and your allowance time is 0.100. The total you added up your normal time and then your allowance, you're going to get 1.100 standard time, and this we also call it time standard or standard time, the same thing. And your hours per unit is here 0.01833, and your dollars per hour is your labor cost that you're paying, and then you have your dollars per unit right there. So this, you multiply that and this, okay? Then hours per unit right there, 1 divided by hours per unit, which is your 1 unit divided by 0.01833, and you're going to get your pieces or units per hour. So we're going to go here for your total utilization and percent utilization. That's for your operator and that's for your machine. So how do we do it? Total utilization is nothing but either operators on this side or machine on that side, and you're going to add all of their operation time divided by operator operation time plus machine operation time. We call this a total utilization time. Okay, so you will get in decimal. You can change that decimal to percentage by multiplying with 100. So the second chart is the same thing, but here is your proposed method. This is not current, it's just a proposal. So what you're proposing is, instead of doing like in the current method, we're gonna have first, second, and third work element, and the first work operator is gonna load and your machine is gonna be idle. Second, your operator is doing a pre-position and the operator is gonna put the output aside and operator is going to go idle. At that time, your machine is machining. And the third one is your operator is unloading and then your machine is going to go idle. So your improvement by doing this, they propose is going to save about $53,800, okay, per year. And that is for 1,000,000 units production. So when you take a look at it, to the bottom part, we have the same thing, and here is your total normal time. So that's 0.700. Your break time is 0.077, and your time standard or standard time, you add it up and you get 0.777. Your hours per unit is right there, and that's 0.01295. Okay, so your pieces per hour, so 1 divided by this is going to give you 77. So in the current method, we got only 55. And we span the total normal time 1 minute with allowance 0.1. So the standard time for that current method operation is 1.100. And your hours per unit at that time was 0.01833. 1 divided by 0.01833 is going to give you 55 pieces or units per hour of production. Okay. So this is a better method because you're producing 77 and that's only 55. So you can get the difference of how much better for this method. So now we're going to compare the cost. So when you look at it, your present method is 0.01833. Okay, so here. So you get it by multiplying the hours per unit times your labor cost, dollars per hour. So they're getting $10 an hour for doing that. And you will multiply that and you're going to get your dollars per unit. Now for the proposed method, you can see hours per unit is 0.01295. And then the labor cost is the same as $10. And your dollar per unit we got by multiplying these two numbers, and you get 0.1295. Okay, so in proposed method we're paying less to the operator than the current method, so we're getting more work out of them. So here you have the difference is going to give you 0.0538 per unit saving you get. So for 1,000,000 units or pieces per year, you're gonna multiply this, and you will get $53,800 saving. Okay, and this saving is just only for one operator, and we're going in only one operation. Okay, with several work elements. So you have to start to think in a big number of big dollars of whatever you're going to be doing is going to affect the company a great deal of money. And if you do your work real hard, also it's going to save the company a great deal of money. So the last part is right here for the time study cycle. And this is the person who is going to take the time is going to put that in for you. Sometimes you go and get the data and just copy it out. And sometimes you have to do it by yourself. So it depends on the company as well. So how are you going to fill that? The very first one is your step 18. So you're going to add the time study cycles, and that's for each part, okay? Every part you're going to measure what that operator is doing with that part and how much time that operator is spending for that part, okay? Whatever operation they're doing, so one by one. And there are a total of 12 blocks for you, because one operation cannot go over 12 work element. So here you're putting the each work element right there, okay? So in this example, it was a loading, unloading, idle, machine is machining. So we're going to put all of that work element right there, one by one. You measure the time first, and then you put in one by one, and then you total it. So step 19 is you're going to add everything up, okay? And then step 20 is your OCC. OCC is nothing but your occurrences, and that is your number of study cycles. Okay, and I'm going to put right there. So in this case, so out of 12 block, we have 10 work elements. Okay, 5 for machine and 5 for the other one for the operators. Altogether, OCC is 10. So the total time we got is 7.50. Okay, and you're going to divide this with that, and you will get 0.750. So that's your average OCC. So we're looking at one occurrence is going to take about that much of time. And for 10 occurrences, we take this much of time. Okay. Then step 22, we're putting the leveling factor. So that's just the tempo of your operator, how fast that operator is going. Okay, so that's, we put it like 85 to 95%, sometimes 65% for slow people. And so we got our normal time. So that normal time is on the step 23, and that's nothing but your average right here, OCC, times your leveling factor right there. Okay, and that depends on the operator tempo. Okay, and you're gonna get 0.712, usually around 95, okay, 90%. So anyway, so 0.712. Okay, that's what you get. And we're gonna transfer that data to this side by rounding it to one decimal, and you're gonna get the total normal time in minutes per unit and put it right there. Okay, and then you add your break time. You get your standard time. You already got your hours per unit. So every time you produce or operated a unit, you're gonna get the time for that by measuring the time for it. And that usually come in minutes. So you're gonna change that minutes by dividing with your 60 minutes per hour, okay? And you will get minute into hours, and then we will get your hours per minute, hours per unit right there. So that's I explained it in chapter 3 and 4. Okay, so that goes into the 0.01295, and your pieces per hour again, 1 divided by this, you will get 77 pieces. So technique number 3 all the way to 6 is just to know, and you only have to know what the chart looks like and what do we what is that chart about. Okay, so here for Gantt chart, we use it when 2 or more people work together and their activities intertwine. So if you look at it, you should recognize that is the Gantt chart. Okay, and we give a column per person. Okay, the next technique is the multi-machine chart. This one also just to know for our scope for this semester, and we use it when more than one machine is run by an operator. So each machine has a column of each own. Okay, it's a little bit different, see? So if I give you a chart, you should be able to differentiate that is a multi-machine or operation analysis or operator machine or your gang chart, okay? Okay, the next chart is called left hand, right hand chart. And it looks like this. Very similar to operation analysis, operator machine, okay? But here we have left hand and right hand. So we're going into Micromotion study. So we use it for one operator only, representing the operator right hand and the left hand and the right hand. So each hand does an activity which is broken down into elements. So we always break down the activity into elements. Okay, we call that work elements. And then the chart is going to show idle time by either hand. Okay, when one hand is idle, it is referred to as one arm bended. Okay, so if I ask you, oh, what is one arm bended, you're going to give me this definition. And this chart is going to give you the utilization rate on both hands. The last one is your SIMO chart. And SIMO chart, some people call it SIMO chart, or some people call it SIMO, is the same thing. So SIMO means simultaneously doing the motion. And so a new column divided into 5 sub-columns. So for 5 body members, we have our finger, our wrist, forearm, full arm, and then our shoulder. So these are the parts that we studied, okay? So each 5 sub-column is added to left hand, right hand chart on each side of the center line. So here is my center line, your timeline, and here we have 1, 2, 3, 4, 5. And we also have 1, 2, 3, 4, and 5. Okay, this side is left and that side is right. Okay, so but then we have a different body parts. So the sub columns are numbered, and when you look at the number, we're going to put the body parts 1, okay, is being the easiest motion, so that's for your finger, because fingers are really efficient and you have to put least effort. And 5 is most difficult motion, and that's your shoulder motion, because you have to put most effort in order to move the shoulder. So it costs more energy for the operator, okay, to do this activity. Now the columns are all color highlighted, okay? So if you look at it, and you should be able to recognize that is the SIMO chart. So you definitely study operation analysis chart in the operator and machine chart. Technique number 3 all the way to 6 is just to know, but at least you have to know this much, okay? The first 2 techniques, you have to know everything. So you go back to your handout and study all of them in details. 3, 4, 5, and 6 techniques, just to know its overview, okay? And you can read it if you want. So I give you all details in handout. Alright, so that's it for chapter 6.